Dear distinguished guests, ladies and gentlemen, good afternoon and welcome to FOSSASIA Summit 2024. First of all, on behalf of the organizing committee, I would like to extend our sincere regard and thanks to all of you for taking valuable time with us today. And to begin the program, I would like to invite on stage I would like to invite on stage Ms. Aryn Choong, Startup Software Consultant, National University of Singapore. Yeah, let's give big applause to welcome her.
Thank you. Okay, would you like to please join us up in the front? Thank you. All right. Okay, so today's talk, I'll be talking about Agile Practices with Scrum. So it's actually a workshop, so we'll try to make this more hands-on as possible that I can within half an hour. But I'll try to deliver most of the information still within half an hour. Well, the important information. So today's agenda, first we were talking about theory and first principles about Agile, what Agile is actually about and why we want to practice Agile. Okay, and of course the Scrum framework itself, which most of us actually associate firstly when we talk about Agile is Scrum, right? And the peoples and the teams that makes up Agile practices itself. And then of course knowledge creation, because we are here right now in the knowledge economy, so we want to know how Agile works in terms of knowledge creation. Okay, so first let's look at the theories and principle. What is Agile really? Literally, we are talking about fast iterative approach, right? So if you want Agile in a nutshell, just a simple sentence, that's it, fast iterative approach. As long as you have something that needs to be done, any project that needs to be done, you do it in an Agile manner. Basically, you do it in a loop, do it again and again, you learn from it, you get the feedback, you learn from it and you put it back into motion, right? So this is what Agile is all about, literally. Next, let's look at the Agile Manifesto. So back in 2001, right? 2001, 17 white guys, they came together in a ski resort in Minnesota and in Utah, and basically they came together to write this Agile Manifesto. Let's say, okay, this is what Agile Manifesto is. So these 17 white guys, most of them are leaders in the software field, right? Some are from various mathematical field as well. So mathematical professors, writers of books, conference speakers, software managers, all these people, they came together and decide what is Agile, right? So they got these 4 values of Agile in their Agile Manifesto. Individuals and interactions over processes and tools. Not that processes and tools are not important. Processes and tools are very important. We need them, right? In this technology world, we want to have processes and tools, but we need to first and foremost think about the individuals and the interactions between you and I, right? Individuals interactions first before we look at the processes and tools. If we can't get individuals interactions right, processes and tools, they don't stand much. So first the individuals interactions, then only you look at processes and tools. Look at the working software over documentation. Documentation is important. We are not disagreeing with that, but your documentation means nothing if your software is not working, right? So working software first, then documentation. Customer collaboration over contract negotiation. Back in the days when we have waterfall methodology, right? You deal with waterfall methodology, we talk about contract negotiation, we talk maybe 1 month, come out with contract, write out all the details, and then, okay, you pay this much, I deliver in 9 months. No, we want customer collaboration over that 9 months period, right? We want the customer's input throughout the whole project. So we want customer collaboration first before contract negotiation. We also want to have some sort of agreement, but we also want to have customer collaboration, right? Responding to change over following a plan. The whole key here is responding to change. Agile methodology is about responding, adaptation, right? So responding to change is more important than following a plan. You have a plan, yes, but that plan, if it needs to be changed, change the plan. Okay? We want to change. A plan is good, but allow for change in your plans. Okay, next, let's look at the complexity of product development. So usually that's how it looks like, right? If you have close to certainty and close to agreement, it's a very simple project. Then a waterfall methodology is more than enough, right? Then if you have far from agreement and far from certainty, nothing is sure, then you have anarchy. Basically, everything is just messy. That's just one word, mess. There's nothing else. But in between, right, this is where most of our projects lie, right? You have some sort of agreement, you have some sort of certainty, and whether it's complicated or complex, this is where Agile comes into play. Agile is best to deal with this sort of projects. Okay? So what is Scrum? What is Scrum? The name Scrum, where does it come from? Right? Who plays rugby here? Anybody? Oh, you have a rugby player. So you do Scrum in your rugby teams? You do Scrum in your rugby teams, right? Yeah, so Scrum in rugby, basically, they try to get the ball. This is a Scrum group, right? They come together with your team, the whole mass of people. They come together and what their goal is. Their goal is to get the ball slowly, by trying to get the ball slowly closer to the goal. Literally, that's what Scrum methodology is about. Everybody have the same goal. We have the same software, right? That ball, bring that ball closer to the goal. Okay, so this is Scrum. And what's within each sprint, right? This circular iterations, what we call each iteration is a sprint, let's say, right? For software development, that's what it is. For the software development life cycle, right? We have plan, then after planning is what? Define, then execute, then test, right? Once you implement, you always have to test it, right? And then review. Very important in Agile technology is that you have to review everything that you do. Have that review inputted. So basically what we are talking about is each iteration. We are doing in each iteration exactly the whole entire software development life cycle in each iteration. You repeat the whole software development life cycle again and again and again. You plan, execute, test, review. Plan, execute, test, review. So on and so forth. Okay. All right. So Scrum is actually an empirical approach. What is empirical? Right? When we talk about empirical, we're talking about historical data. So when you collect a couple of data together, then it becomes data to be able to work on, to be able to act on, right? So that's what empirical means. You actually base your actions based on data, based on actual observation and experience rather than anything else. Don't do it because other people say so. Do it because there's actually data to prove. Okay, so that's what empirical means. So empirical process itself, it actually requires courage. Why? You must have trust and courage before you can have transparency. Transparency is because you have that transparency, then only you have that information for everybody to share, right? Be transparent about your own failures, be transparent about your work, be transparent about the outcome, transparent about your values, all this. You must have trust and courage between your team members, between the organization before you can have transparency involved, right? Once you have transparency, then only you can have inspection. Then only you can look at it. You have inspection, you have the data, you inspect it, and then you adapt to the situation, adapt to the data that you have, right? So that's why you see this progression. You have trust and courage comes first, then only you have transparency in your organization, then only you can work on that data to have inspection and adaptation, then only, right, thank you. Then only you reach the goal. Okay. So Scrum values is very important. Why is values important? Values is important to the individual. Each of us, our values are important to us. As a whole, values is important to the organization because once you have the values clear cut, then only everybody in your organization knows that, okay, this is what we are working towards. So everybody has the same goal. Everybody has the same direction. That's why values are important. That's why Scrum also, these values are important to get to the goal, to be able to achieve what you're trying to do. Okay, so let's have a look at the Scrum framework now. So this is an important aspect of Scrum framework is the time boxing. Time boxing is important. You want to have a particular time set for every single event in Scrum. So if you say, okay, so this meeting will be for 1 hour, make sure that that's called time boxing. Say you want to time box a meeting to 1 hour, it will never ever reach outside 1 hour. So it's more than an hour. You say, okay, this is too long. Let's cut short. Let's do it in another session, or saying that, okay, this meeting has been dragging too on. It's not achieving anything much anymore. It's digressing. All this is what time boxing is trying to fix, is trying to avoid. So let's say, okay, everybody has heard of stand-ups? Lovely. Okay, so this is why I would like everybody from the back to come all the way to the front. Please join us in the front. There's a lot of empty spaces. Please join us at the front. Let's do this very quick exercise. This is a workshop, so I'll need you guys to do a little bit quick hands-on exercise. So everybody, very quickly give your background, who you are, what you did in the last 24 hours, what you plan to do in the next 24 hours. Okay? So I'll set the timer right here for us. Okay, and we'll start. So I'll start first. My name is Aryn Choong. And last 24 hours, I did a city tour of Hanoi. And next 24 hours, I plan to enjoy the rest of FOSSASIA lovely sessions today, as well as tomorrow. How about you?
Can you ask again? Sorry. Okay. Hello everyone. My full name is Zang. I work as a Scrum Master in a company about transformation of PropTech. It means PropTech of Vietnam. This morning I have some meeting with my client in company, so I really excited about Agile and Scrum that you will present today. So I come there and I really want. I have some problem and some question to ask you about real situation that I face in my company. So I hope that you can help me to resolve them. And after this event, I really want to expand my network to have more community, and especially if you have time in Vietnam, I really want to hang out with you or have some cafe to discuss about Agile. Thank you so much.
About yourself?
Hi, my name is Zang. I'm a computer science at PTIT. At 24 hours, I spend a weekend at home, and next 24 hours, I'm going to attend FOSSASIA Summit.
Oh, hello everyone. I'm a final year student of Fenica University, and I'm working on an NLP engineer, and also attending it to gain the knowledge about this field. And I want to participate in a workshop to apply its Scrum and Agile in personal project, not enterprise project. Yeah. That's all. Thank you.
Hi everyone. My name is Nguyen. I'm currently a senior student in the IT field. So in the last 24 hours, I study at home, and the next 24 hours I will spend my time in FOSSASIA Summit 2024 and attend every workshop that I can. Thank you.
Hello everyone, I'm Hill, and I'm a developer at the website field. So last 24 hours I I'm hang out with my friend and play badminton. So the next 24 hours, I will maybe I need to review some tasks from my members. So yeah.
Hi, Rayshon here. I'm currently a full stack software engineer with Outsource Digital, based in Singapore. In the past 24 hours, I flew in on a Vietjet flight to Hanoi from Singapore. Next 24 hours, I will continue to attend the rest of FOSSASIA Summit. Yeah, thank you.
Hi, my name is Nikhil Kathole. I'm from India. Yesterday, I explored Da Nang. From there, I took a flight to Hanoi last night, and today I'm attending FOSSASIA and preparing for my talk. And in the evening, I'm planning to explore the Hanoi. Yeah.
Good afternoon, everyone. I'm Nguyen. I'm Vietnamese, but just come back from Singapore. Last 24 hours, I was enjoying my time with my family, and now I'm here to learn more about the Agile Scrum. Thank you.
Thank you.
Hello, everyone. I'm Dong. I'm a software engineer from Viettel Group. And the last 24 hour, I had a trip to my hometown with my family. And the next 24 hour, I will attend the second day of this conference.
Thank you.
Yeah. Hello, everyone. I'm Thao. I'm from Vietnam. Last 24 hours, I spent time at home. And the next 24 hours, I come to FOSSASIA Summit. And I will have a talk session after your session. And in Vietnamese also.
Hi everyone, I'm Huy. I'm work together with Thao. Last 24 hours, I spent a lot of time for my talks. We will have a session after you, and the next 24 hours, I think I will spend more for me, for myself.
All right. Thank you very much. Okay. And basically, look at that. What we did was just in 6 minutes, right? It does not take a lot of time to do a stand-up. Okay. So next, let's me introduce what is a Scrum team, right? A Scrum team literally mix up of a development team of less than 10 people. So no more than 10 people. Like just now, we talked about who we are. Last 24 hours and next 24 hours within a Scrum team of 10 people. That's how long it takes, 6 minutes, that's all. Okay, so why a development team? So in Scrum, a development team is basically a team that manages itself. The manager does not give you any work. It does not assign you jobs. The team itself will assign themselves their work and their job. That's what we mean by manages itself. And the team itself creates the done increment. We'll talk a little bit more about the done increment later. Okay, each Scrum team has a product owner and one product owner only. What does the product owner do? The product owner owns the product backlog. It basically takes care of what goes into the product backlog, and his job is to optimize the value of the product, to be able to tell, okay, from the product backlog, what is the priority? What should be done first, right? And each Scrum team can only have one Scrum Master, no more than one Scrum Master. So that Scrum Master basically only manages the Scrum process itself, right? He also removes impediments. So traditionally, in a traditional mindset of software development, the software manager is the optimum person to be the Scrum Master. So in this case, if you are a software manager of a team, you would say, okay, let me take on the Scrum Master role. You manage yourself. I take care of any impediments. Basically, if you have any issues, I take care of it for you. You do the work, you manage yourself. I take care of any issues from the outside. Okay. So let's look at Scrum itself, okay? We have the Scrum events and the Scrum artifacts. So what's the Scrum? It takes, okay, so it takes up the sprint. The sprint is the key of the Scrum itself. So one sprint is from 1 week, no less than 1 week sprint, no more than 4 week sprint we are talking about, right? So no more than 1 month. Every time you have a sprint, if it's more than 1 month, it's no longer Scrum already, right? So each sprint is no less than a week, no more than 4 weeks. And before you start your sprints, you have your product backlog. Remember, the product owner is the one that comes up with the product backlog. And the product backlog is basically organized in terms of priority. So the top stories at the top are the highest priority stories. And then you have less and less priority. So the product owner will come in and say, okay, this is the highest priority. I will move it up to the top of the product backlog. And of course, there is a product goal. Every time there is a product backlog, there is a product goal. And then we will take the top stories from the product backlog, we will put it into the sprint backlog. So the sprint backlog is basically all the tasks required to complete the sprint, whether it's 1 week or 4 weeks. Of course, once you have the sprint backlog, you can very easily determine what is the sprint goal from the sprint backlog. Then at the start of the sprint, what we do is that we have a sprint planning, no less than one, actually, I wouldn't say no less than hour, but the time box for the sprint planning is no more than 1 hour for a 1 week sprint, no more than 8 hours for a 4 week sprint. Daily Scrum, what we did just now, our stand up, right? We stand up and we talked about what we did in the last 24 hours, what we plan to do in the next 24 hours, any impediments, basically any blockers that is you are facing for you to complete your work. So these are the 3 things that each team member will stand up and talk about. It's literally a space where we update each other on our progress. What are we doing, right? We ask each other every single day for no more than 50 minutes. Just now we went a round of 10 people and it only took us 6 minutes, right? So it should not take more than 50 minutes for the daily Scrum. Okay, so for a team, you can decide when you want to do the daily Scrum, whether you want to do it in the morning, when you everybody see, okay, everybody is in already, let's just do our Scrum, our daily Scrum. Stand up and then just tell each other what you did in the last 24 hours, next 24 hours, any blockers, that's it. If you want to do it in the end of the day, 5 o'clock, everybody, okay, let's just stand up, do our daily Scrum, also can. It depends on the team itself. Okay, so the increment is basically any phase of the working software. Every single iteration of the working software will be called an increment. It does not have to be at the end of the sprint. It could be in the middle of the sprint or anything, right? Basically the complete working software, that's what we call an increment. So the last increment that you have in the sprint, we will bring it into our sprint review. So the sprint review is done at the end of the sprint, of course, and it takes no more than 1 hour for a 1 week sprint, no more than 4 hours for a 4 week sprint. Okay? And after the sprint review, okay, the sprint review is usually where sometimes you want to bring in the customers. So the customers come in and then, okay, let's look at this sprint. Let's review, what is correct, what is, I think that, needs some tweaks, needs some changing, feedback from the customer. All that is done during the sprint review. After the sprint review, then the development team comes together and we do a sprint retrospective. A sprint retrospective should last no more than 1 hour for a 1 week sprint, no more than 3 hours for a 4 week sprint. Okay, so during the retrospective, what happens? So the team, okay, now we've done the work. We have already demoed to the customer. Okay, now, come down. And then what? Then we have to do a review. What do we do in a review? We talk about, okay, how was this sprint? What was good about this sprint, right? What was bad about this sprint that we need to change? And what should we try next? What have we learned about from this sprint? All that is done during the sprint review. Okay, and we also have this, what we call this traffic light, basically start, stop, continue. You reverse it, you can get what was good you want to continue doing, what was bad you want to stop doing, and what that we learned that we want to try next is start. Okay. Okay, then after the retrospective, we have this definition of done. What is the definition of done? Definition done is basically an agreement between the development team to say that, okay, when we complete a task, it needs to meet this criteria before we can say it's done. That's why we call it a definition of done. We define what we consider done. Let's put it on paper, clear cut. If we tick all these boxes, it's done. So that's the definition done. After the sprint review, sometimes you want to think, we decided, we want to add something to the definition done, or we think that something is not necessary, we want to remove from the definition done. Usually, we do it during the sprint retrospective. Okay, so this is your typical process of a sprint, and this is a typical process of Scrum. Any questions, we will leave it to the last, okay? We will try to continue as much as I can within half an hour. Okay, so a sprint is actually an agreement between who and who? Anybody can say? Anybody? It's actually an agreement between the development team and the clients, the customer in this case. So basically the development team is saying that every sprint, you, the customer, you can have us do everything you want, anything that you want us to do, you can tell us. Every sprint will let you do, say whatever you want, right? Tell us what you want. And basically, this is the promise to the customer. Okay, we allow you the flexibility of your own product. And this is also an agreement from the customer to say to the development team, say, we will leave you alone to do the work. We trust you to be able to complete the work that you said we want. We told you that we want already, okay? So this is the client's promise to the development team of stability. Say that we will let you do whatever it is for that sprint. We won't interfere with you. After the sprint, we can tell you something new that we want, okay? So this is what it means by a sprint is an agreement. Okay, we probably have only enough time to talk a little bit about what people means in a Agile methodology. When you talk about people, what motivates people? Anybody? What motivates people? What motivates you? Money. Recognition. That's great. Rewards. Actually, what motivates people, interestingly, is actually autonomy. What's autonomy? Autonomy means the ability to do what I want. That's autonomy, right? That's motivation. If I can do what I want, I want to do it. That's everybody also feel the same, yeah? The ability to organize my own work, right? This is what actually motivates people, right? Mastery of my own work, to become better at my work, to do better, to be improving of my work, to have the purpose, to make a contribution to the work itself. These are the three key items of what motivates people. Okay, so to be able to shift from the red zone behavior to the green zone behavior, you want to be listening and responding instead of listening but not receiving. You are talking, you don't receive. You don't want that. Okay, this is bad behavior. You don't want to respond defensively. You want to be calm. You want to be casual speaking. You do not want to feel wrong. Don't feel defensive, right? Don't feel wronged. Have an open behavior. Open about your faults. Open about your mistakes. Open to be changing. Don't get involved in battles and antagonism. You want to welcome feedback, right? Feedback is the only way we can learn. We want that feedback. Don't have an enemy perspective. Mutual success is important, and to have collaborative excellence. We want to work together to get to quality, to get to excellence. Okay, so that's people. And next, let's have a quick look at teams. What does teams mean in Agile? Agile, you hear this very often. It's all about continuous. You want to have sustaining pace. Okay, so continuous innovation, continuous integration, continuous development, continuous improvement, continuous pace, sustainable pace. Sustainable pace means that you want to have that continuity. You want to have it at a right pace. You don't want it to be too heavy pace. Okay, then everybody just fall straight away. Okay, too tired already. I cannot continue. No, you want to have it continually. So it has to be a sustainable pace. Okay. Always have cross-functional team. Everybody understand about cross-functional team and T-breath team. Have this in mind when you develop your team. And we don't want a complete harmony. Complete harmony means it's not actually improving. Everybody agree with each other. That's it. We also do not want to have war. We do not want to have contest or fortification in the team. What we do want It's actually productive design. We want you, okay, yes, if you have anything that is opposite thinking, tell me about it. We want to improve on that. I want to see each other's different diverse opinions, perspective. So this is a conflict response mode. You have accommodating at one end. If you have a lot of avoidance, that's where you are. If you have a lot of assertiveness as well as a lot of cooperation, you will be at the highest green end, which is engaged collaborating. We want to have that. Okay, I don't think we have time for knowledge creation, so I'll skip that. Thank you very much. If there's anything, this is just a quick look at the different slides that I won't have time for, but thank you very much. Please give me your feedback. Thank you.
Ok, chào mọi người. Chắc là mình sẽ bắt đầu luôn cái phần mọi người. Mình là Nguyễn Văn Thao và đây là Trần Mạnh Huy. Thì bọn mình đến từ một cái group gọi là cộng đồng gọi là học chủ động. Thì I see some foreign in here, but my session is Vietnamese. But you have any question? Feel free to ask us about this. Yeah, thank you. Yeah. Thì bọn mình đến từ cộng đồng học chủ động. Đây là một cộng đồng mà bọn mình thường xuyên chia sẻ kinh nghiệm cũng như là giao lưu về các cái phần mềm mã nguồn mở. Thì bọn mình có một trang web là học chủ động.com. Trên đấy thì bọn mình chia sẻ khá nhiều bài viết về các cái phần mềm open source. Bọn mình rất là đam mê tìm hiểu về các phần mềm open source và bọn mình cũng rất mong muốn được đóng góp cho cộng đồng. Chính vì thế mà hôm nay bọn mình đến đây để giao lưu và chia sẻ với mọi người một cái use case. Nó cũng không mới nhưng mà nó cũng khá thú vị về việc bọn mình làm thế nào để bọn mình tự động hóa một quy trình ghi lại nhật ký vòng đời của một cái hạ tầng. Thì phần trình bày của bọn mình sẽ gồm 4 phần. Đấy là các cái issue, các cái vấn đề mà bọn mình gặp phải trong cái quá trình mà thực hiện việc ghi log của nhật ký của hạ tầng, các cái giải pháp mà bọn mình tìm hiểu được, làm thế nào để bọn mình automation cái phần đấy, và cuối cùng là một phần demo nho nhỏ để cho trực quan hơn. Thì mình bắt đầu.
Như Thao vừa giới thiệu, thì, công việc chính của bọn mình là hiện nay là đang quản trị phần hạ tầng hay còn gọi là cái phần infrastructure. Thì đối với một quản trị viên như bọn mình thì bọn mình quản trị tất cả cái hạ tầng phần cứng của công nghệ thông tin, từ những cái thiết bị mạng như là router switch hay là server phần cứng, hoặc là những cái sản phẩm về storage. Thì đối với một người quản trị viên như bọn mình ấy, thì cái khi một hệ thống nó được dựng ra và để nó duy trì được tối ưu nhất thì bọn mình cần phải có những cái công tác là lưu trữ thông tin hoặc là giám sát. Thì trước đây thì bọn mình sử dụng cái công cụ truyền thống thôi, theo những cái phương pháp tự phát. Thì bọn mình sử dụng cái file Excel ấy để lưu trữ những cái thông tin đấy. Tuy nhiên là khi mà cái phần hạ tầng công nghệ thông tin bên mình nó phình to hơn, lên đến hàng nghìn những cái thiết bị chẳng hạn, thì cái công tác mà mình quản lý thông tin bằng cái file Excel đấy nó sẽ bắt đầu có những cái bất cập xảy ra. Thì ví dụ như là khi mà có quá nhiều cái thiết bị đấy thì cái việc mà các bạn update thông tin hàng ngày thôi thì nó cũng đã tốn rất nhiều cái nguồn lực và thời gian rồi. Chưa kể là do cái yếu tố con người nên là nó sẽ bị đâu đó nó có thể nó sẽ bị thiếu sót thông tin ấy. Và ngoài ra là cái việc mà đảm bảo tính nhất quán dữ liệu và đồng bộ thông tin của thiết bị cho các thành viên trong team hoặc là cho các lãnh đạo cấp cao hơn ấy, thì nó cũng là một cái vấn đề mà mình cần phải lưu ý. Thì đấy là cũng là những cái vấn đề bọn mình gặp phải và đã thôi thúc bọn mình tìm hiểu ra những cái sản phẩm open source khác để thay thế cho những cái cách quản lý thông thường. Thì ở đây là bọn mình lựa chọn sử dụng công cụ là checkmk và netbox. Thì mình cũng xin phép giới thiệu qua một chút là checkmk là một công cụ mã nguồn mở sử dụng để giám sát toàn bộ hạ tầng công nghệ thông tin. Thì đối với mình thì đây là một sản phẩm khá là tốt vì nó sẽ cover được hết tất cả các thiết bị bên mình. checkmk này thì nó cũng được base trên một cái sản phẩm Nagios, nó cũng khá là lâu đời, tuy nhiên là đã được bổ sung thêm khá nhiều tính năng và cũng có một cái giao diện khá là thân thiện để cho người quản trị viên có thể vận hành và thao tác trên này. Công cụ thứ hai mình muốn nói đến là netbox. Netbox này là một công cụ mã nguồn mở được phát triển bởi DigitalOcean. Mọi người có thể hiểu thì nó giống, cái netbox này là giống như một cái sản phẩm, nó giống như là một cái quyển sổ ấy để lưu lại toàn bộ thông tin của các thiết bị. Thì đối với môi trường doanh nghiệp như bên mình thì thông tin của các thiết bị nó có thể là thông tin về cấu hình con máy chủ này, mã thiết bị này, rồi kết nối vật lý này, thậm chí là những IP hay là máy ảo, thì tất cả những cái thông tin đấy hoàn toàn có thể được lưu trữ trên cái sản phẩm sản phẩm netbox này. Một cái tính năng khá là lưu ý nữa là trên cái công cụ netbox này mình hoàn toàn có thể lưu lại nhật ký của cái thiết bị ở đây. Bọn mình tận dụng cái tính năng journal này, mọi người có thể hiểu là nó giống như là sử dụng để lưu nhật ký. Thì các cái entry như trong nhật ký thì nó có thể là sự kiện khi mà một cái server được khởi tạo này, rồi khi nào nó sử dụng bị quá tải này, xong rồi khi nào mà có một cái dịch vụ nào đấy trong máy chủ nó bị crash ấy, thì đấy là những cái sự kiện mà bọn mình ghi nhận lại. Thì khi mà một người quản trị viên như bọn mình về sau bọn mình nhìn lại đến những cái sự kiện này thì bọn mình hoàn toàn có thể biết được là cái tần suất nó xảy ra có bị nhiều hay không. Thì dựa vào đấy thì bên mình sẽ ra những cái biện pháp khác để phòng tránh nó bị xảy ra lại trong tương lai. Ngoài ra thì đối với cả các team lead ấy, thì khi mà họ nhìn thấy thì họ có thể là nhận định trong cái thiết bị đấy nó chạy có ổn định hay không và dần dần đưa ra những cái biện pháp khác thay thế. Thì đối với cái tính năng này thì bọn mình phát triển thêm một cái biểu đồ dạng history graph để dựa vào đây thì mình có thể có một cái nhìn trực quan hơn về hệ thống. Khi mà có một nhân sự mới chẳng hạn thì mình khi mà mình chuyển giao cho họ thì họ cũng có một cái nhìn khá là trực quan và dễ dàng hơn.
Thì khi mà bọn mình áp dụng cái công cụ này vào ấy, thì bọn mình cũng giảm được khá nhiều thời gian và nó giúp tối ưu hóa công việc khá nhiều. Tuy nhiên thì bởi vì đây là hai cái công cụ riêng biệt cho nên là nó đang không có sự liên kết với nhau, và bọn mình vì vậy nên mình tiếp tục tìm hiểu để bọn mình muốn toàn trình cái quy trình từ lúc cái con VM hoặc một thiết bị nào đấy được khởi tạo lên, sau đấy thì có những cái sự kiện gì xảy ra với chúng thì nó cũng sẽ đều được ghi log lại. Và bọn mình quyết định là đi theo hướng event driven cho cái sản phẩm mà bọn mình xây dựng. Thì bọn mình tìm hiểu về một cái giải pháp, tiếp tục là một giải pháp open source nữa, đấy là Ansible Rulebook. Thì bọn mình nhận thấy rằng là trong cái hệ thống công nghệ thông tin mà bọn mình quản lý ấy, thì hàng ngày rất nhiều các cái event mà nó được sinh ra. Ví dụ như khi là một cái máy ảo nó bị down chẳng hạn, thì đấy nó là một cái event. Và các cái event đó thì trước đây ấy, vì bọn mình không để ý, tức là bọn mình không sử dụng nó và nó gần như nó không mang lại giá trị gì cho việc tra cứu cũng như là tra soát sau này. Thì bọn mình quyết định là bọn mình nhận thấy rằng là những cái event đó cũng cho cái phần ghi nhật ký của bọn mình. Thì cái Ansible Rulebook nó là một cái sản phẩm mới của Ansible và nó giúp toàn trình hóa cái quy trình tự động hóa trước kia. Nó sẽ liên kết được các cái phần event, nó có một cái bộ gọi là thành phần gọi là suộc, tức là mình sẽ các cái event mình sinh ra trong hệ thống ấy, thì sẽ được connect về Ansible Rulebook. Sau đấy nó sẽ có một cái bộ rule filter các cái event đó, lấy những cái event mà mình mong muốn. Sau đấy thì nó sẽ trigger một cái action để thực hiện cái hành động mà mình muốn cho cái event mà mình thu thập được. Thì như ở đây mọi người có thể thấy rằng là các cái event suộc ấy, thì có thể đến từ rất nhiều nơi, có thể là một cái hệ thống công nghệ thông tin hoặc là một cái một cái con thiết bị phần cứng nào đấy. Sau khi mà cái event đấy đó được sinh ra thì nó sẽ được cấu hình để nó bắn đến Ansible Rulebook. Thì Ansible Rulebook sẽ thực hiện cái việc filter sau đấy và nó sẽ trigger một cái playbook. Ansible Playbook thì khá quen thuộc với lại đa số những người quản trị làm về hệ thống rồi, bởi vì nó là một cái công cụ kịch bản. Mình sẽ define, mình hiểu nôm na là mình sẽ define ra một cái kịch bản cần làm gì và sau đấy người quản trị sẽ trigger nó để nó chạy. Sau khi chạy xong thì nó sẽ stop. Thì tuy nhiên cái việc trigger bằng tay ấy trigger là cái việc start thì nó vẫn sẽ làm bằng tay. Cái việc start này vẫn làm bằng tay. Và khi mà mình áp dụng Ansible Rulebook vào đây ấy, thì mình sẽ tự động hóa được cái phần mà trigger cái playbook đấy.
Thì như Thao cũng vừa chia sẻ thì Ansible Rulebook thì bản thân nó sẽ mang một cái kiến trúc khác, nó sẽ kiến trúc về cái event driven architecture hơn. Là đây là một cái kiến trúc mới, mọi người có thể đã gặp đến cái kiến trúc microservice rồi, nhưng mà đây là một kiến trúc mới. Mình thấy ở Việt Nam cũng bắt đầu nhen nhóm, mọi người các đơn vị cũng đã bắt đầu sử dụng rồi. Thì, nhờ có Ansible là một cái công cụ trung gian nên là bọn mình đã ứng dụng được cho rất nhiều những cái quy trình của bọn mình có thể tự động hóa hoàn toàn. Tuy nhiên là đến tham dự buổi hôm nay thì bọn mình sẽ chia sẻ hai cái use case mà gọi là phổ biến nhất và bọn mình hay sử dụng. Thì ở đây là mọi người có thể nhìn thấy là khi mà một người dùng trong đơn vị của bọn mình mong muốn khởi tạo một con máy ảo, máy chủ đi, thì netbox đầu tiên nó sẽ thu thập thông tin khởi tạo của người dùng từ các cái hệ thống tạo ticket. Sau đó thì netbox sẽ gửi một cái event, một cái sự kiện đến Ansible. Ansible sau đấy sẽ dựa vào cái payload, tức là những cái thông tin của event đấy và quyết định sẽ thực hiện những cái hành động gì tiếp theo. Thì ở đây là sau khi mà nhận event xong thì Ansible sẽ gọi đến hạ tầng ảo hóa bên mình để tạo máy chủ này. Sau đó sẽ tự động add lên hệ thống checkmk để giám sát luôn. Và cuối cùng là gửi lại thông tin cho người dùng. Thì trước đây là cái công tác mà khởi tạo máy chủ và khởi tạo và add cái máy chủ đấy lên hệ thống giám sát là bọn mình phải thực hiện bằng tay. Sau đấy là thu thập lại thông tin và sẽ lưu lại file Excel như mình có chia sẻ ban đầu ấy. Thì nhờ có Ansible và các cái công cụ mà đi kèm thì bọn mình đã tự động hóa hoàn toàn được cái quy trình này. Một use case thứ hai để sử dụng được cái event nữa là đối với cả một con server đã được add giám sát lên hệ thống checkmk, thì khi mà có một cái vấn đề bất kỳ gì đấy xảy ra đối với con server đấy thì nó sẽ đều là một cái entry trong cái nhật ký mà mình vừa chia sẻ ở trước. Thì sau khi mà Ansible nhận được cái event đấy, nó sẽ update ngược lại lên trên netbox này để lưu trữ thông tin. Đối với một số những cái sự kiện mà nó đơn giản ấy, chẳng như là con server bị tắt này hay là service nó bị crash, thì Ansible hoàn toàn có thể trigger ngược lại đến hạ tầng để self healing, tức là start lại cái con server đấy hoặc là start lại cái service đấy luôn.
Alo, tổng kết lại thì sau khi mà bọn mình áp dụng cái quy trình tự động hóa đấy thì bọn mình đã tiết kiệm được khá nhiều thời gian, công sức cũng như là làm tăng cái hiệu quả quản lý. Mình cũng giảm thiểu được cái rủi ro mà khi mà người dùng hoặc là người quản trị quên update vào trong cái các cái phần mềm giám sát cũng như là các cái phần quản lý của bọn mình. Ngoài ra thì bởi vì là mình làm việc với cả phần mềm mã nguồn mở, vì vậy nên là như mọi người có thể thấy là bọn mình customize được các cái phần như ví dụ như là gửi cảnh báo đến cho Ansible hoặc là từ Ansible update vào journal của netbox chẳng hạn. Thì những cái đó nó sẽ phụ thuộc vào tùy từng công ty, tùy từng các cái quy trình mà bọn mình cần phải làm. Thì đối với open source ấy, thì bọn mình có thể là tham dự vào cái quá trình đấy, customize được nó một cách dễ dàng. Tuy nhiên thì cũng sẽ có một số khó khăn, đấy là bởi vì là open source, tuy nhiên là cho nên là bọn mình sẽ phải tìm hiểu và nghiên cứu. Thì để trực quan hơn ấy, thì mình xin phép được gửi đến các bạn một cái demo nhỏ nhỏ về cái phần tự động hóa cái việc update từ một cái event lên trên journal của netbox. Chắc là mình bật một cái video mình đã chuẩn bị sẵn từ trước thôi. Đây. Thì đây là một cái VM của bọn mình. Quay lại cho em, quay lại đoạn đầu. Mình giả sử đây là một cái VM trên hệ thống của bọn mình. Thì VM này đang được chạy. VM này đang online. Thì bọn mình sẽ add nó lên checkmk để giám sát các cái thông số về disk, về CPU các thứ. Đó. Con này thì cũng nó có một cái quy trình trước đấy, khi mà bọn mình tạo ấy, thì nó sẽ tự động được add lên checkmk và netbox. Thì đây nó cũng đã được add lên netbox để bọn mình quản lý các cái phần liên quan đến thông tin của nó. Alo, bọn mình sẽ sử dụng cái journal đấy để quản lý phần đấy. Và bọn mình giả định một cái cây là ví dụ như là cái con VM đấy nó bị tắt chẳng hạn, thì cái nhật ký đấy nó cần phải được ghi lại trên cái hệ thống quản lý của bọn mình. Thì khi mà nó tắt, checkmk nó sẽ nhận ra rằng là con đó nó tắt và nó bắn một cái event cho netbox, cho Ansible Rubok thì đúng hơn. Thì Ansible Rubok sẽ bảo netbox cập nhật cái trạng thái đấy vào trong cái nhật ký của tao. Tức là phần con VM đấy nó sẽ bị down đi, và cái thông tin về việc mà nó bị down thì sẽ được cập nhật vào trong netbox. Cứ bật đấy. Đó, thì đầu tiên thì checkmk nó sẽ nhận ra rằng là ở cái service của agent của nó bị stop, thì nó sẽ cập nhật vào trong netbox. Một thời gian nữa thì nó sẽ nhận ra rằng con đấy nó bị down rồi, và nó sẽ tiếp tục bắn một cái event nữa. Thì cái này nó nằm ở phía quản lý của mình thôi. Tức là nếu mà mình muốn config service down bắn event, hoặc là host down bắn event cũng được. Đấy, load controller 2 đã bị down, và bọn nó cũng sẽ bắn một cái event là ở cái host này tao đang nhìn thấy là nó bị down rồi, và nó cập nhật vào đây. Thì sau khi mà cập nhật xong thì mình sẽ tiếp tục là bật con VM này lên và xem nó cập nhật cái trạng thái của con VM đã quay trở lại vào trong netbox. Đây, mình sẽ bật cái con VM này lên. Ok, đây là con Ansible Rubok. Nó sẽ đợi cho đến khi mà checkmk nó nhận ra rằng con này đã được bật lên rồi và có một cái event được bắn đến, thì nó sẽ trigger một cái playbook để cập nhật cái trạng thái mà nó đến vào trong netbox. Đây, nó đã cập nhật xong và mình sẽ vào netbox kiểm tra. Đó, như vậy là nó sẽ cập nhật là ok, cái host này đã lên. Và mình cũng có thể xem cái journal timeline của nó như cái phần mà bọn mình trình bày. Thì bọn mình cũng custom cái này để cho ví dụ như các cái cán bộ quản lý họ có thể xem một cách dễ dàng hơn. Ok, thì đấy là cái phần demo của mình. Thì chắc bọn mình cũng trình bày xong và cũng chia sẻ xong về cái use case mà bọn mình áp dụng. Thì nếu mà mọi người có câu hỏi gì ấy, thì mọi người có thể hỏi bọn mình. Bọn mình có 25 phút đúng không ạ? Bọn mình có 25 phút, chắc còn 5 phút nữa. Nếu mọi người không có câu hỏi gì thì mình xin phép được kết thúc bài trình bày chia sẻ về cái use case của mình tại đây. Cảm ơn mọi người.
Software visualization is a very broad topic that covers a lot of the SDLC, but given today's time limits, we'll be talking about a few specific aspects of it that would help us. So let's just look primarily only at code-based visualization. So why software visualization? Studies show that developers, we spend more than 25% of our time just navigating through a code base, whether it is good code that's highly modular, structured, or as code bases eventually tend to become spaghetti code. So why do we do this? As we navigate through this code to answer a lot of our questions. These are just a few of this, like from understanding what a code base does to identifying specific data flows, function flows, or even like what are the modules dependencies, and a lot more. And when we do all this, we keep a lot of this information in our heads, and these are called mental models. But but surprisingly, not all of us have the same mental models, because software is very hard to visualize to a real world metaphor. Now, although throughout the SDLC, there are many places where we have diagrams and visualizations. Like the most common thing that many people would be familiar with are UML diagrams during the design phase, where we have diagrams such as the class diagrams, sequence diagrams, and use case diagrams that enable you to explain the structure of a software to people, right? And then when you move on to testing, deployment, and monitoring, you again have a lot of visualizations that enable you to show how software is working, its behavior. But when you think about the implementation aspect, the aspect where we spend a lot of our time in, we don't really have a lot of visualizations. Now, software visualization is not a new concept. The goal of software visualization is to identify mental models and metaphors that can help translate software to a physical metaphor that people can easily understand. Why are we doing this? Because that is how we can communicate with each other about the software that we develop. So this domain has been there for more than 2 decades, and that book particularly was written 2 decades ago, and that indexes every single effort that was done by various researchers over time to describe how a software evolves. This becomes very necessary when you're thinking about scale of a software. Maybe like when you build a project that's initially small, you actually put in a lot of effort to structure it and then design it. But then as your code bases grow, which naturally happens in enterprise settings as well as large open source projects, millions of lines of code, how do you communicate that? That is where software visualization can help. Now, software visualization is broadly categorized into three areas. One is the software structure, the other is the software behavior, and then the final thing is software evolution. Software structure represents the static structure of the software, and this is where most of the design diagrams that we currently use are also fall under. Software behavior is kind of hard. It depends on the technology stack that you use. There are certain technology stacks or domains that can directly translate to good visualizations for the behavior. For example, robotics. You have a lot of things like behavior trees and simulations that can show you how your software works. But what about an enterprise resource management system or a warehouse management system or an order booking system? It is hard to visualize the behavior of these things. The final thing is software evolution. Here, this is an interesting topic because as your code bases are not static, it's not done in a day. This evolve over time, and as things evolve, a lot of people work on the software, and a lot of things happen, and multiple parallel changes keep happening in your software. There, you can analyze all of this data. We'll get to some cool visualizations there, and you can analyze a lot about dependency tracking, change impact analysis, and you can make decisions about whether to refactor my code, optimize my code, and performance evaluation, etc. So with that overview, that is software visualization about structure, behavior, and evolution, let's get into the challenges and the benefits of software visualization. So many of you, as I keep talking about UML diagrams, many of you, depending on the language stack that you use, you may already be familiar with a way to auto-generate your code diagrams from your code, such as if you use Java and Eclipse or IntelliJ IDEA, or if you use tools like Star UML, which is what's represented here, you can actually draw out these UML diagrams, and then that can get generated into stub code from which you can start working. And some of these extensions also generate these diagrams directly from your code base automatically. But they have their limitations. Now, this is a very simple system that has like 5-6 classes. Now, think of a 5 million line code base. When you auto generate a UML diagram, that's just going to be a lot of classes, and you can't actually you'll have to spend a lot of time filtering through it, and then getting it to a place where you can make some sense out of your software system. So then researchers at that point in time we represent software, especially very large code bases. That is a cityscape. So for this, people, what since software does not directly translate to a physical metaphor, people have been trying to identify a lot of metaphors. One such metaphor is a cityscape. Now, this again is a very old visualization, but the idea behind this is every single building essentially stands for a class or a function, and then a collection of buildings could be a class, and then an island could be a module, and then your lines that connect each of these islands are your dependencies and imports. Now, these kinds of visualizations have their benefit. You can actually see how big your code base is, but they have their challenges as well. Like I'll talk about. Imagine again a 5 million line code base that you generate the cityscape for. How do I read this? If I don't have any idea whatsoever of what I'm looking at, I'm just looking at a diagram, a very complex diagram. Does not solve the use case. But despite that, these cityscapes have stuck around for a very long time. Now, this is an open source project that you can check out right now. It's explorevis.dev. This works on Java code bases. But as you can see, here again, you see a cityscape. This is a pet clinic sample project that's on Java. So this is how it's visualized. As you can see, each of these individual modules, and then the classes and how they are connected to each other, how they are imported, all of this are now thrown into mixed reality, but the idea is still being the same. And this would also have the same problems when you go to a larger scale. There have been other ideas on how we can better represent our code bases. Now, this is a project, this has shut down right now, but the idea behind this project was, can we have a better way to enable people to understand our code? Can we logically group our code in ways that can better translate to our mental models? So here again, the code is analyzed and then it's categorized into different like execution points, like the entry point, then where initialization happens, then where the functions are defined. You can actually logically navigate this code base. This, of course, is better, but then again, the same problems of your language. Many of these tools are language specific. They can only work on Java, they can only work on C++, or they can only work on C#. And then there's a lot of work that goes into explaining this code to you. Most of these systems work with static code analysis and not actually use any sort of logical understanding of what is happening. So because of which you are limited by visualizing a structure. Let's see how there are other tools in the other ecosystem. Like these are some Python examples like that will enable you to extract your dependency graphs. And on the top there you see Wistracer. Wistracer is an extension that you can install that will actually show you how your function is or your class is executing, and then you can see how long it takes, and you can navigate your code base that way. This helps you in optimizing your code. And at the below, this is actually a research effort that took place a while back, wherein when we're looking at code bases for optimizations and refactoring, would it be good if researchers or like the developers actually got signposts in their code that can actually tell them exactly how much time a particular line of code is taking? Now, again, this did not actually materialize into a usable open source product, but researchers are always working on these kinds of things. When we come to evolution, as I mentioned earlier, we have all this metadata that is around the code. It's actually very interesting that when you think about it, it's not just the code, but your version control history and your project management data, your metrics. Can we actually visualize that? And when we visualize that, can we infer any meaning? Can we understand things about how our code base works and how our team works? Here is another open source project. It's called Gorse. This actually which takes your metadata around your code and then starts visualizing it as a Bloom diagram. And it shows you how over time, how many people were working on what projects or what parts of the module. And then it shows you over time how your project is evolving and then who is working on what. Now, this is exported as a cool little movie to use, but can you actually get more data-driven insights from these videos? As you can see, as the timestamp on the top keeps moving out, the project kind of stabilized after a while, and then the users are only working on certain modules and like improving it, keeping it up to date. You can actually get this information right out of your code base, metadata. Now, this is another project called CodeScene. This is not completely free. There are certain aspects that are free, but it's also paid. The idea here is those insights that you just saw in the video, they can actually be visualized as usable metrics. So from code hotspots to architecture to team dynamics to system performance, all of this information extracted directly from your version control metadata. So what are code hotspots? For people who are not familiar with code, hotspots are the regions of the code where a lot of activity is happening. This is important when you want to actually identify the areas where you need to do a lot of refactoring or optimization. If basically the rule of thumb is that if a lot of people are working on one single file, then that file needs to be split across and to make modular. So to make design decisions, such visualizations become essential. This talk, there's actually a talk specifically about this and how what all insights can be derived from your metadata. It's called Your Code as a Crime Scene. It's also a book. It's an interesting way to look at code. But despite all of this, if you look at our stacks today, we don't actually use a lot of visualizations. We just open up our IDEs and we start writing code. Why is that? Like I mentioned earlier, a lot of the time, it's about not having an intuitive representation that you can actually immediately transfer your ideas to. And there's a learning curve with any of these visualizations. You have to spend a lot of time understanding how these visualizations help us. And some other time, these visualizations are not automatic. Like, let's say you're using OpenTelemetry, and then you'll have to instrument every part of your code if you want to visualize your optimization and performance. Then maybe these things are not easily integratable into your existing workflows. They are, as I mentioned earlier, they are very, very stack focused. Like some things work only for Java, other things work only for C#, and other things work only for C++. And sometimes, but more importantly, it's all this information overload. There's no way for any particular person when you're looking at very large code bases, they're overwhelmed by all the information that they get and they lack the context that's required, because you don't need to see all this information every single time. There are maybe one day you're trying to understand your code base, but other days you're just trying to find out how a particular function flow works. But this again is an open problem. It's not solved. But can we actually make a more focused, intuitive, and stack agnostic visualizations that can enable us to understand our code bases better? Right now, with the evolution of generative AI and better code understanding, these things could become possible. There are three key things that need to be solved for us to generate usable visualizations. From the first aspect is code understanding. How do you understand large volumes of code? And the second thing is, what are these metaphors and mental models? Or if people have different mental models for to understand their code bases, can we have a visualization engine that can actually represent those unique visualizations for each people? And then that's basically context-based personalized representations. And then you finally need the technology to enable that. AI agents today, like GitHub Copilot or any other code understanding tools, do work for small uh, number of lines of code. Like maybe you can take a 2000 line code and then ask GitHub Copilot to generate a sequence diagram for me, and it will actually generate a sequence diagram for you. They to diagram right now, we have a lot of these languages such as Mermaid.js and Draw.io. These are all descriptive languages like LaTeX, if you're familiar with that, wherein you can describe a diagram, because of which it translates very well to the large language model use case, because then it's essentially just doing text to text. It is trying to understand one form of text and then describing it in another form of structured text. So you can actually try this out today. You can take any small code base and then ask Copilot to draw a diagram for you. But then as these code bases scale, even Copilot or any other large language model for that matter cannot out of the box describe that diagram in great detail. They become very abstract. So if I'm trying to explain a simple order management flow, if it's a very small system, I'll actually get descriptions of the exact classes. But if it's a very big application, then I'll actually that basically say order inputs, order processing, order validation. That does not actually give you details about the exact implementation, but only a high level overview of what the code base is doing. And they may or may not be correct, because hallucinations and correctness and repeatability of large language models are a problem. But you can work around this too. There are certain approaches, but since the technology itself is very new, all of these research activities are currently in progress. There's a lot that is happening in software visualization research today. So from understanding what our mental models are, how do each of us think about the code base, and how do all of us keep all of this information about a particular code base in our heads while we can't really describe it? Because it is easy for a person who has been working on a particular code base to explain everything about it to you. And while this person is translating all this thought from his head to English or whatever language, there's a lot that's happening from converting a mental model to understandable standardized models. Then there's work on trying to understand exactly the cognitive load, the learnability, the emotions that surround people when they are navigating these code bases, and how can visualizations deal with the increasing trend of this complexity? Because as I said, these visualizations currently don't scale to very large code bases. And this last work, can LLM-based agent workflows be used to understand code and visualize code better? That is actually an open problem that even our team is working on. We are Wipro Lab 45 Research. We work on a lot of these upcoming research areas, from software visualization to robotics and other domains that involve a lot of generative AI. This is our work, and we are making progress, but software visualization as a domain still actually can benefit from a lot of your inputs today. And if any of you find any of this interesting, you can always yes. Okay, cool. Yeah, so if you all find this interesting, then there's a lot of ways you can contribute, like from going to finding out all these open source projects that I mentioned earlier, and you can start contributing today to that, or you can actually get in touch with the researchers that are working on this, like us, or there's a small website that at the end that's a softwarewiz.wordpress.com. So there, it's a community driven project wherein researchers are indexing every single effort that is happening in this space as much as possible. But very soon we could actually end up in a place where we are not just coding with text in our IDEs. Maybe we are programming visually, and we can describe any kind of a project, a system, using visual data, and then navigate from visualizations to code directly, because all that could become possible soon. So with that, I'd like to conclude my talk for today. Thank you. Yeah. Mm-hmm. No.
It's a 900-page book describing the process of visualizing large-scale software.
Yeah.
We have been applying that in my software for a few years. He has been
Mhm.
I do presentations today about
Okay,
software
okay.
visualization.
Yeah.
So that's the reason that I'm here. I wanted to talk to you.
Sure.
To showcase and see if we can collaborate.
Definitely. Happy to. Thank you. Any other questions? Okay. Thank you. Thank you then. But yeah, my name is Nikhil Kathole. I'm working as a principal software quality engineer at Red Hat. And I have been working since last 3 years on testing software as a service platform for Red Hat. So today we are going to discuss about the continuous delivery and testing in software as a service. But before that, let's take a quick look on the today's agenda. First, we will look into like what is software as a service for those who are not aware about it. There will be a quick introduction about. We will look into the one of the strategy that uh, we are showing off here, and as a subcomponent of it, we will look into development methodology where how the services are built or developed. We will also look into their deployment pipeline, how those are getting deployed, and we will also look into some of the testing challenges and how the testing is done. So, software as a service. I think everyone here already heard about what is open source. We all know open source dominates the software ecosystem, right? And with time and with rise and increase from the demand, like cloud is also gaining the popularity. So we can say like this softwares, open source softwares are moving to the cloud platform uh, in terms of some delivery model, and that delivery model which is nothing, we can call it as a software as a service. So basically software as a service is nothing but is a distribution model in which different cloud providers, they host their applications, and whoever wants to use it as a user, they just go ahead and subscribe it to it, and they can basically start using it. uh, if you look into the architecture, traditionally we had many monolithic architectures, but going with the time and with the new cloud native services, we are moving to the microservices. And this involves like front end as a service and then back end as a different service, and also the database as a different service. So this is the integration where all this come together and we get in user experience out of everything. And this is again one of the reason where this SaaS becoming a popular choice amongst the users, because they just need to go to cloud provider, opt in, subscribe to it, and they start getting whatever the requirement of their business, they start getting to use to it. One of the challenge like they had like managing the infrastructure or the deployment, that is gone with this option, right? So but in SaaS, like there are two things which matters the most. The first is speed and the second is accuracy. So when we are talking about the speed, user wants this new features coming up on their experience very fast. They don't want to wait for it, since the world is changing, AI is coming up, and they want the things pretty faster. So that's why one of the reason, like if we have to build our software in quick and safe way, we need to follow some strategy behind to achieve that. So basically, don't sacrifice your software quality for speed. Uh, as I said, like this model is getting evolved and this is getting adopted fastly. Thus, we also need to modify our monolithic testing strategy as well. I have here the three pieces of the guidance which we have divided into. The first is software development lifecycle, where these services are built. The second is continuous delivery pipeline, like how these services are deployed in different environments before it's going to production. And the last is operational monitoring. So once you deployed any service on the production environment, then that's not where you stop. You also need to monitor and you also need to make sure your users are getting correct experience. And each of these different steps or the different pieces, those are supported by the different metrics. That means we are monitoring this each step and we are learning out of that, and we keep improving out of that. So let's take a so here are some things about the development methodology. I'm not going to into the each and every point, but the most important one and the most applicable, which are not in our traditional model of software development. We are going to these 3 quick points where we think like these are the some of the important things in case of developing the services. So the first is quick cycle of small code changes. As I told, like speed is critical in this SaaS model. So customer or the user need these features very quickly. So there is basically it's gone are those days where customers are looking for or the users are looking for one of the release and they're waiting for a month and quarters and years, right? Customer wants these features very fastly and they want it very quickly. So these short cycle of the commits that help the features and the fixes to go into the prod early so that users can use it and they see value out of it. So this also like gives basically automation engineers a time to develop the automation. Whenever a developer develops something and that goes to the production, your stakeholders, QE stakeholders or quality engineers, they can go ahead and write the automation for a particular function. And going forward, one of the important thing we are going to discuss is automation is key to the deployment pipeline. If you have the automation in place, you can release your software pretty quickly. So that's why like small code changes, rather than pushing the big whole bunch of the code once in a release, we are talking about here like we should commit each commit to the prod, or we are talking about here we should do the small changes in prod once in a time. And this could be either daily, or either this could be weekly, or this could be even the multiple times in a day. The next is short-lived branches. So if someone is working on, if as a software developer you're working on a feature, rather than having it in separate long-lived branch, you start developing it, and this could be feature flagged in the production environment where a certain set of users can use particular those services and test it. We also call this as the beta or the preview environment. Also the architecture consideration, this is the important stuff here, because here we are talking about the integration where one service depends on your another service. So if you are developing different services, microservices, then you always has to be on the latest code of your dependencies. So that it won't break into the production. So make sure you are always on the latest code of your dependencies before going to the production. So these are some things which I wanted to talk about the development methodology. The point is like the code only is helpful to user when it's in production. The next strategy point is the deployment pipeline. So as I talked earlier, like this is the cloud era, and this is very much faster. So each step in the CI/CD pipeline has to be automated. It has to be have some kind of metrics and some kind of getting for that. So here we are talking about all systems should be monitored by some matrices here. So when we talk about the different steps, those are like development, build, test, deploy, and finally the release. So if you see the diagram here, as a developer, developer goes and create a PR, that is pull request. then as a stakeholder of QE or the quality engineers, you go ahead and add a test around that as well on the PR by deploying the particular change on the ephemeral environment. And these ephemeral environments are nothing but like the short-lived environment, which you can use as a temporary environment to test your changes, to automate around that. So whenever the PR gets merged, you already have the automation running on the next environment. So here, the code change, as soon as it gets merged, it gets deployed to the further environment. Here we are calling it as a stage environment, where again the certain tests like the regression test, functional test, integration test, whatever you have, those are getting monitored. And if you see, there is gating mechanism involved in every promotion of the code from either your PR to the production. You have the gating mechanism at all the places. So if you see, like, what if something goes wrong? You also need to be make sure that if something goes wrong, you can roll back or you can revert the change within a few cycles of your releases. So that's why the matrices that we are talking about, those are critical, and you have to monitor your systems in all the environments to catch the issues proactively. So that's the reason the operational monitoring is also important here. So when we are talking about the operational monitoring, we have different things to take care of here. Like, so the first one, alerts and the notifications. When something goes wrong, you make sure the right stakeholders are getting alerted before it becomes a problematic for your users. The next is the dashboards. Here again, like we talk about the different visualizations mechanisms using different tools. Like you have a number of open source, like the OpenTelemetry, Kibana, and even the couple of the monitoring tools like Splunk. Those can help you to create the alerts and dashboards so that you can monitor your users or you can monitor your application before it becomes problematic for your users. Third is the logging. It's also important, like it is possible that your functionality is working fine, but your server is getting something wrong, or it's throwing number of errors, or it's getting out of memory. So you have to monitor your whole system, starting with your different matrices like CPU, what's its memory, what's the network input output throughput, so everything. So that's why logging is also the important to monitor the aspect. And the last one is the user metrics. How many times I think there are a number of applications where particular user service needs to scale as per the different occasions. Let's take an example where if Christmas comes in and shopping, the software as services which are related to the shopping and everything, those users gets the number of users, those are gets high in that particular time, and in such cases your service can broke, right? So you also have to monitor that user matrices so that you get ready for that. You can scale the service as you want, and you can basically make sure the customer experience is great. So these all the things that we divided into the piece of the guidance. And finally, some of the testing challenges that we are going to discuss here. As I talk about, like, these releases happen so frequently, couple of times, multiple times in a day, right? So here, as a QE, you need to make sure you are selecting the right test cases for the right promotion of the code. Here also, we have to make sure, like, less testing of the software elements, but more demand of the software testing. That means your test cases has to be selected, but you have to run it frequently so that if something goes wrong, you get the risk, you get notified on the risk of the particular software, and you can basically work on that quickly. The next challenge is how to always be ready for release. Since we are talking about a particular change that can go to production, and you have to make sure nothing is at risk due to that particular change, then you need to make sure like what we are testing and how much time it is taking. So that's why it is said like the continuous testing isn't as simple to implement, but it adds exceptional value to your business. The next thing is progressive delivery or the feature flag. So if you have heard about the progressive delivery, that is nothing but the you enable your service on the production for a certain number of users, and you start measuring your scalability and the performance of your application, so that you can measure like how the service is doing using this progressive delivery feature. And also the feature flagging, where you are enabling the service for particular users, and you are getting the feedback from them. So this fast feedback out of them, and you are making the changes as per the requirements in their services. The next is testing in production. This could be sound weird, but yeah, this is testing in production. You have to make sure like this can multiple times be happening to you, like services are working fine in the pre-production environment, but in production it may break due to the dependencies or due to the so the point is you also have to make sure your services are working in production, and you have to continuously make sure like you're running some set of test cases in production as well. We call it as a shift right testing. As a QE, it is also important that you need to have the understanding of services and the data flow. So why we are talking about here like services and the data flow? The challenges with the software as a service like is one of the challenges migration of the data. So if you have implemented some change in the database, so your previous data should be intact. Those should not get changed because you deployed something new. So database migrations and the understanding of your services, this is really important as a quality engineer to understand. And finally, testers' expertise in customer experience. One of the big aspect of this is in monolithic or in traditional softwares, you get access to the logs, you get access to the resources, you get access to the application where it is deployed. But in SaaS, you just get the front end as a user. So user may see the functionality is working fine, but user may also have to see like what is happening in the backend. So that understanding is important in terms of the customer experience. So it is also important like whoever is looking into your services as a quality, you have to make sure the customer experience is also good. So I think the whole point is continuous testing for SaaS is very important, and also you have to make sure you involve the QE or the quality assurance engineers early in the cycle, either in the planning phase or either in the requirement phase, where they get the understanding of what you are delivering. So I think that's pretty much out of it. Any questions or anything if you'd like to ask? Yeah, please. So there are multiple things involved here. The first one is the functional test cases that sometimes we go ahead and hit the APIs. We make sure we are getting the response out of that. The second time is like, let's say there are some test cases which are making sure the backend functionality is working fine. And the last is the monitoring, where we set the different Prometheus and Alert Manager and the Splunk, using which we get to know like if something is going wrong. So that kind of stuff comes into the production testing. Yeah.
So you said you are exposing this to the public when you say that testing in production that you have served.
Yeah. Yeah. It's yeah. So it depends on feature to feature. So like sometimes, as you say, like it could be the A/B testing, or it could be the feature flag, or it could be the progressive delivery. Yep, please.
Do you have like any real-time monitoring? You were mentioning about monitoring stuff, so you can kind of take decisions based on
Yeah.
fresh data. Let's say there's something that the anomaly is where I need to react to this. Maybe.
Yeah, we do have one example where we use which do the real-time monitoring, and we generally check the data on hourly basis. If something goes wrong in the last hour, we get to know at the end of the hour, and we take the actions accordingly.
And this is the actions are automated, and you can
Yeah, yeah. Okay. Yeah, if anyone has any questions, you can also discuss after the session. Thank you. Yeah.
Best way possible always. I love that. So my name is Tomaz Canabrava. I work for CodeThink, and I am a free software advocate, and I work for free software for 20 years. I joined at KD on 2004, really, really long time ago. I am 40. And currently I'm working with Codevis, which is a framework for large-scale software analysis. I'm also a developer for Bloomberg, for KD, and for Arch Linux, because apparently I have no better things to do than to code. And I have no pointer, so I will always come here. When the software architecture is wrong, there is no way for you to fix that in the future, or when there is, it is too costly. It will spend thousands and millions and billions of dollars working, trying to get something that is horrible to something that will be maintainable in the future. And the result will always be subpar. As soon as you are starting a company, if you do not pay attention to software design, your company will not scale. And that's an important thing to pay attention to, because open source software, closed source software, it does not matter. If you started your software without taking care of the architecture, you will not get far. Or it will, but it will cost a lot. Also, if anyone wants to interrupt me, please do. I have no problem being interrupted constantly. And I know that sometimes my English is really fast, so just poke me and I will repeat slower. So what the hell is Codevis? It's a lot of things at the same time. It is based on the book Large Scale C++ from John Lakos. It is also a software that will be applied to way more languages than C++. Currently, we support more, but we plan to have most of the good languages, of the languages that are being currently used in the world inside of our toolkit. We have specific code already for Python, PHP, Java, and C#. Not fully working. That's the reason that we are not integrating with it yet. And it already works. It's already helped fixes issues in LLVM, in the Qt Foundation, and the KD repositories. Each one of those things here have more than 2 million lines of code. At least LLVM has at least 5 million. Qt has around that. KD has 85 libraries and 400 software. And we were able to ingest all of that and fix issues. And it's also being used by Bloomberg. Bloomberg is sponsoring this project, so I need to say, be honest with you, that a large company is sponsoring my work, but it is also being useful for them. This is Codevis, and this here is also Codevis. This is Codevis analyzing Codevis itself, because I need to use what I produce to make sure that the thing that I'm doing will help people. And what you see here is each compartmentalized library from different aspects of Codevis, and disposition matters. Things that are in the bottom do not depend on anything. Things that are directly above it depends on the things that are in the bottom and subsequently. So this thing here can depend on everything. This thing here depends on nothing. So as soon as you look at this, you already know which is the most important thing, the foundation. And then you know how your libraries interact. But you see, the code that I just told you that I did, it's also a mess. It is a lot of information here, and just by looking at this, you have no idea, you have no clue on what to do. It's the problem that we were discussing about. It is just too much data to analyze for a single human person. But let's advance. So we have analyzers. We make sure that we are ingesting large scale code bases from day one. From day one, we were ingesting LLVM, Qt, and the KD libraries. And those, in a sum, is more than 10 million lines of code. So we always try to make sure that our software was ready for production. Not good, not perfect, but ready to be used in real software. The visualization framework and UI is decoupled from the algorithms that does the analyzers, so you can run the analyzers anywhere, and then you visualize the results. And a plugin system, because I might be a genius, I am not, but I might be a genius, and I might think that I know better than you everything that you need to use. And then I might forget things. There is maybe something in your projects, in your company, that you want to visualize in a different way that I did not take care of. So we have a plugin system to fix those things. We support, on the language level, Clang, which will ingest C, C++, and we also support Flang, which is the Fortran compiler of LLVM that will ingest Fortran. But why am I on 2024 looking for Fortran code? Isn't Fortran dead? No. Fortran is still used inside of supercomputers, and no company will ingest, no large-scale company, no company that actually has data centers that run supercomputers will use my software if my software does not use Fortran. So Fortran is also there, and Fortran can interact with C and C++. As soon as you parse your project, you will see those interactions. Everything that we did on Codevis, we found errors in Qt. We found errors in LLVM. Every time that we found an error, we fixed that error in the library, and we send all of the contributions back. So we are helping upstream, because this is extremely important. Open source can die if there is just users and never contributors. So for you people here, seeing open source for the first day or using open source on a daily basis, help open source. Why CodeThink might be useful? I have no idea. I am a researcher. I am trying to understand why Codevis might be useful for companies. But we found security issues just by analyzing graphical interactions within modules. The XZ attempt Linux hack this week could easily be spotted by Codevis because it was trying to use something that was not on the original file. So if you download it, try to compile, analyze the results with Codevis, you would see a cyclic dependency there that should not be there. So this could be useful for security audits. It could be useful for re-engineering automation, applying AI on engineering and then changing codes, regenerating the graph and seeing if things should be like that. Developer onboarding process, which is something that we already discussed, and visual templates for code and technical documents. What else? We have CI integration. We have 3 CLI applications that can run on your CI or in a distributed system that will generate the information that you need, and then you can deploy the results in database on AI to feed a large dataset model, for instance. If you do not have a CI and you just want to use your desktop application, also useful, you just click in the generate project. That will bring you this table here that you fill the information. That will then generate things. And it's fast on your computer because it will use as many cores as possible, as many cores as you have. It can also be used distributed. It will use a local database, so you are not stuck on a server. You can distribute your database, or you can use that on a server. And then that we will be using for visualization and data transformation. And this is the easiest version of the previous graph. This is easier to understand to what I showed before, but it's actually the same thing. Because here I did not explode, I did not show the entire catalog in once. So ignore the names that I'm using for libraries. I am obliged by contract to use those names. True. But it's quite easy to see here that I have a problem. I have a problem because one of my lines is pointing up. Because one of my lines is pointing up, that means that I have a connection from here to project, project to loader, loader to something. I have no idea what this is. And then this is a cyclic dependency. This is hard to solve. This is hard to fix. And this is an architectural issue on my application that I added there on purpose to verify that my thing was correct, generating the correct graph. As soon as you find this kind of thing, you can say, this is wrong. We need to stop what we are doing. We need to fix this before the software gets too complex. But we have no idea where it is because this is folders. So we need to expand the folders to see the files. And then you see file to file, which is the file that it's creating the dependency. And then you expand the file and you see the exact methods or exact functions that are generating the dependency. And then you split. Then it's easy. The problem is to find those things. Here we have everything from every single library that your software depends, independent of computer language. So if you compiled something in C that used C++, that used Fortran, everything, every library will be here with every single thing that the library has. So you're not just analyzing your code, you're analyzing the entire data set. The main view is drag and droppable. It's dynamic. One thing that you also said on your talk, that it's hard to have dynamic graphs, dynamic capabilities on those, because tools, they currently work by generating one static graph, and then you need to look at that and infer all of the information that you have. I hated that. I hated GraphViz because of that. Anyone here already worked with GVPR? Nope, you are lucky. GVPR is an aberration created by GraphViz in the 70s and 80s, which is a command line tool to filter graphs. It's a complete programming language to filter graphs, which is undocumented, horrible to use, full of bugs, and the only thing that companies had until, I don't know, 5 years to filter large data sets. So now we have a dynamic view that can load, unload, multiple tabs, split views. You can create, you can remove, you can analyze, and you can add documentation directly on this to showcase to your colleagues. Navigation, expanding, this kind of thing. We have also an information box. As soon as you move your mouse, we can add more information dynamically to that box. This is also plugin based. So you see that I'm not actually producing a lot of code. As soon as I have the data, I need to analyze it. And analyzing is one of the most complex processes that there is. I can also search, because as soon as I have 1 million nodes here, it's impossible to find just by looking at it. So I type what I need and I quickly jump. And the possibilities. We found an architectural issue, we found a cycle, I found something, but I have no idea what. We relay those to plugins, because my software will never be able to implement everything that your software might need. So the plugin system can add new things on the UI and can add new things on the canvas. The canvas is the drawing part of the graph. It can also look directly into the database. And it's done on Python or C++, because Python is useful if you want to distribute, and C++ is useful if you want to use internal on your company. You do not need to open the source, and you need to make it fast, because Python is really good for prototyping, but as soon as you need the speed, as soon as you are going on a multi-million graph, Python will not go. And it's simple and direct, simple. We ship with example plugins. We have a plugin that will look for code coverage, that will analyze your Git repository and display on the view how much of that file, how much of that folder is covered by unit tests. So as soon as you drop on the view, you see 80%, 90% directly. It also has a cyclic detection. So I actually have an example of cyclic detection. So yeah. And we have a Lacosian rules. Lacosian rules is based on the large scale C++ book. I don't think that anyone here care about that, but some companies do. So we wrote that. This is the cyclic detection plugin. We drop something on the view, right click, detect cycles. It will look for your large scale stuff, and then it will highlight the cycles. Click on the cycle, you'll see here what class, what file is having the cycle, so it's easy for you to go there, fix manually. We do not solve the cycles for you yet, but we try to. And then advance. And then you need to fix and regenerate your graph to make sure that the cyclic relationship is gone. More cycles, cycles. I just said everything here, but if you want to take a look, because my English is not perfect. So the cyclic analyzer just analyzes visually the elements loaded, important, loaded, not the entire data set. Because if it is the entire data set, it might take too long. And sometimes you know more or less where the cyclic is, but you are not sure. And it will find the cycles, you click, you analyze, and you make your software more maintainable so that people in the future will not try to kill you. And this is, again, base plugins in study. So we are studying right now on creating an AI architecture analyzer. It will load your codes and try to guess if your architecture is good or not, and maybe try to tell you how you should focus that. Your talk also had something related to that. I mean, our talks were really similar, but focused on completely different things. That's impressive. Also, code metrics, different styles of code metrics from different researchers. We have a knowledge island that you also talked about. I think that I have the same talk here. And automatic library splitting based on code levelization. This is nice. So take a look here on the first. Here. I have some libraries that are really small. Those are okay. I mean, I have 5, but I have libraries that are really, really big. I probably could find here in this a cluster of elements that are not being used by anything else. So I can cut this on a line, and then I can separate those things into different libraries. And just by visualizing, it's easy to spot on where those are. We actually have this plugin working already, which is really cool. We implemented it last week. That's the reason that it's not in the stock, but we have that. You select, we generate a text file that you take a look, and then you move your files into a different library. I mean, we tell you what to do. We don't do it for you. And go back. And AI-based hotspot visualization. You also talked about that, about hotspots and about AI. But basically, without running the codes, what is most likely to block your program and what is the biggest possibilities to fix? We do not have that. This is just an idea, but it's a doable idea because we can infer by using perf data, running the code, analyzing, and then showcasing exactly where your program will get stuck or trying to, and how to fix. And if you want more plugins, you can implement yourself. I can help because this is completely open source. This is completely free. I do not want to know that your company is using it. I want people to use and tell me, Tomaz, you are a horrible developer. Please fix your bugs, because this helps me. But a few corporations already are using, and they already have tools for that. But the tools suck. The tools are usually static code analyzers for package managers, CMake, Bazel Ninja that generates graph of the building system, or software installation packages like APT and Chocolate that will look for the graph of the installation things. But those things, they just care about the software, not the source files. They care about the compilation step. And that I don't really care, because a compilation unit has nothing to do with the maintainability of the software. And I want a software that I work for 20 years, and like I have here. I want a software that I worked for 20 years to still be useful in 20 years. I do not want people to throw away my code because it's unmaintainable. So why did I create that? Because I got paid to. Because it's easy to develop locally, refresh the UI and see the changes. I do not need to wait for instance, a GitHub or a Grafana or anything else to run on top of it. And Grafana and GitHub, there is a lot of setup involved. And this is basically zero setup. You point the software to your source, you wait, and then you have the results. It's easy to integrate plugins because no software will do everything that we want. So we need to make a way for people to integrate the things that they want. And it's easy to integrate visualizations for the same reason. Success stories, yes, Bloomberg, it's using this already. Yes, KD, which is the biggest open source community. We have more than 2,400 people. It's also using this on some software. What else? For developers, this is open source and permissive. You don't need to pay, you don't need to tell me, I don't care. Merge requests, I accept, and I will love you forever if you send merge requests. And plugins can be used for closed source organizations. They don't need to tell me, they don't need to push upstream. We are corporation friendly. And do I still have time? I don't know how much time do I have, maybe. Some. So to onboard people, because the software works on visualization, you can create a visualization for your new software, for your plugin, for your architecture. You can document that, and that can generate, because we also add that, you can generate source code from the visualization. So it can ingest code and it can also spit code. So it's easy to get something small, allow a user to take a look and see, understand the connections, and then work on top of that before just showing a lot of code for him and deal with it. This is a 1 million line of project. You need to deliver something by 2 weeks. That does not work. Architectural visualization is also good, and dynamic documentation. This is really, really nice, because documentation is important for the viewer, and it will also be used when you are generating codes, and it can also be ingested when we are reading the code. And IPC from text editors. This is really nice. So I implemented on Codevis dbus. People here know what dbus is? No, it's a way for two applications to communicate with each other. So if I have Visual Studio Code or CLion, as soon as I open CLion with a plugin, a tiny plugin for Codevis, they can send a message to Codevis. Load this file that I just opened so I can navigate on my editor, on my preferred VI or Emacs. As soon as I navigate, Codevis will show exactly where I am on the file that I am or on the class that I am, which is also really cool, and it helps. It's not something that will save your life. It's a helper, and it's a tool for you to gain knowledge on a source of code source. Documentation plugin, and more meaningful templates. Yeah, that's also a bonus. You can generate source code from C++, Python, Fortran, based on Python templates. So if your company hates the templates that I use for mine, change it. Don't even need to recompile the software. And you select what you want to generate, because you might be showcasing too much for the user and he is just interested in a few things. And it will generate all of the classes, all of those files inside of those packages in a way that's already compilable into a library. It has no contents. It has the functions, it has the classes, but the functions have no contents. That's architectural. That's not architectural. Those are algorithmic. And because those are algorithmic, Codevis does not care yet. Maybe we will care in the future. So summarization, you can create architectures and dump its skeleton. You can analyze pre-existing core architectures. It's plugin based system, so you can create something or reuse something that someone else created. It's good to study the architecture of a software. This is my talk. I can showcase the software for those that are interested. It's running here. And my name is Tomaz. I am a C++ developer. Please save me from myself. Any questions? Yes. Sure. What about the domain-specific languages? We do not have a plugin yet for domain-specific languages, but it's easy to add. We added support for Fortran in 3 days. All right? So basically, we have a database schema that was taught to hold any kind of language that it's either structured or trait-based or object-oriented. So if you try to parse Haskell, might be a little bit of a problem. But for anything, Lua, JavaScript, PHP, I would say that if you have a library that knows how to parse those languages and you just get the tokens, it's a 1 or 2 day job to implement. Did you try something with, like, let's say, kernel? We parsed the kernel, yeah. And we parsed the kernel. It worked in the first try, which is strange, really strange, because we wanted to have something in C to showcase the visualization of 3 functions. Because when we are dealing with C++, we have classes, so we do not show functions. It's easy to bundle 20 things, 50 things inside of just one node. But as soon as you have functions, as soon as you have one function calling another, as soon as you have callbacks, this changes. So we used the kernel and we used SQLite, which is also in C. We had a crash with SQLite. We fixed the crash. We also send them a patch, but they don't accept patches. They rewrite everything that you send. But yeah, it works with the kernel. So how it feels like with, let's say, kernel, you use certain configuration, some certain parts are there. Yeah, it will not handle that. So what happens is, as soon as you use kconfig to generate your kernel configuration, you use bear to go through the make file and generate a compile commands.json, and then we ingest that compile commands.json. So if you have multiple different ways, you need to create multiple different views. It's impossible to do what we requested because we are using Clang. But we are not using Clang as just a parser. We are using Clang to expand all of the macros in analyzing time, and also to handle all of the template expansion from C++. So we actually know every single template and every single possible expansion that your software did. But as soon as you do an if-def 0, we lost that block. Any more questions? Nope. Thank you for your question. I like to talk about the kernel. And this is it.
Different kinds of architecture, bare metal, different kinds of operating systems. So we built our CI/CD service to satisfy our requirement. So that's EulerPipeline. The Compass CI is the base. Hello? Of the EulerPipeline. So I will start with the Compass CI first. It is the scheduling and executing system, which is the most important thing of any kinds of complexity systems like building or testing. Often need the infrastructure to schedule resources or executing your job in the remote node. So let's start with the Compass CI. Compass CI is declarative. All the job of it you submit. All the job is declarative. You just need to submit a job YAML for announce the parameters you need, or the operating system, the kernel, or the task box node. All you need to just submit the YAML, and it supports different kinds of kernel, different kinds of machine, different kinds of software, often to serve your requirement for building or testing or benchmark, or just borrow simply to borrow a machine to use. That's what I'm talking about. Just if you need a bare metal or a VM or container, all of them are supported. And Compass CI is in a microservice architecture and maximum of 16 containers. The picture of 3 layers is the 3 layers is all of the Compass CI, and the red one is others. I will introduce later. For the bottom one, the local run job layer is about some setup scripts, some monitor scripts like the main info monitor, the CPU info monitor, etc., and the statistics script and the run job script, which to run your task or builds program. The local run job layer will happen in each task box you borrow. And the middle layer is the remote run job layer, and it is about some service run in the remote manager node, like some life cycles, the main scheduler, all the quiz, all the database, and other service. And the red one, the project specific pipeline will serve. It is different kinds of applications. So for different things, like if you need the building systems, and that is EulerMaker. So we build EulerMaker, our OS building systems based on Compass CI, and the EulerMaker is the extra service on the top of it. And the EulerPipeline I will introduce later, and it is also a red layer application. The EulerMaker will I will not introduce today because this is not my section. It will be introduced in tomorrow 2:30 p.m. in room 202. If you have any interest of it, you could join the section tomorrow. So back to my session. I will continue for a Compass CI. Once the user submit the job YAML, the task box will grab it from the scheduler quiz. Once it grab it, it will use these 4 ways to prepare the environment needed for the job. Instead of installing, because we know if we install a operating system on a machine by the original way from like ISO or a QML image, it will take a long time. But if we use the init ran FS, we use the overlay FS way to make it. It will be very fast. To more specific, the init RAM FS means we will make all the components into one init FS file, and all of the system of the software the job need will totally run in memory. So it will be so fast when you deploy. And the NFS and CIFS way means we will prepare init ran disk file for specific operating system distro, and after we deploy the OS by mount the init by mount the root FS, but it is read only. We will then we will mount the overlay. We'll mount the readable layer by NFS or CIFS, so you could make your job happen on the overlay FS. So it will be very fast. But they the top three ways have a shortcoming. That is they could not persistently to store the data. So if you need to persistently store your data, you need to use the local disk way, which means the root FS will mount on your logical volume. So that is the 4 ways we support. So we don't do the install. So that's the way how Compass CI deploy. Error is inevitable. Every time we submit a job, and the job will perhaps the job will occur different kinds of value, like the picture on the left. The statistics show that there is several values happen. So for Compass CI, the Compass CI will submit submit the git bicep tracing for each of it. For each of the arrow, Compass CI will find the first back commit for it. It will consistently submit submit the same job with different with different commit hash, and totally find the first batch commits for all the values. So it will make you easy to find out what is the root reason for the error. And for performance testing, use Compass CI. You could make a good comparison between 2 commits, 2 OS, or 2 hardware to find out what is the difference happen, what is the performance change, like the right picture show. That is the basic function of Compass CI, and now we here EulerPipeline, the CI/CD service. Because the basic function of Compass CI is how to schedule and executing job, but it could not make make job and job like run automatically. So EulerPipeline is to resolve this problem, to make a declarative grammar, to arrange all the stuff and drive them by event. So this is the architecture of the EulerPipeline. Is the 1 plus 1 plus n plus m. It means one pipeline is under a certain declarative grammar, like the right picture, by several keywords, and it has n kinds of defined templates served for different scenes, which predefined by the maintainers, and all the templates arrange m kinds of atomic jobs, such as building or testing different kinds of scripts. Finally, the OR pipeline will serve for kernel CI, serve for package CI or distro CI, etc. About the declarative grammar like this, it is very similar like the GitHub Actions one. If you need to define the webhook trigger, you could use the on keyword and announce what kinds of event you need, and Git repo address and the branch, etc. Or you could also use on keyword to announce a cron tab trigger, which is we most to use the interval, how much interval we need to trigger the whole workflow, and the structure of the control flow of the pipeline. You could just use sequence and parallel sections, like the button picture shown. All the red row is announcement of a job, and the parallel and sequence will announce is represent the structure of the control flow. So it's no limited to announce how many jobs are parallel, or how complex structure it is. Like some declarative grammar used in GitHub Action or others, they will basically they are limit the structure's complexity. So this kind of grammar will just make it unlimited. So for the single rectangle, the red rectangle represents there are one atomic job. Like this is Ola Maker create project job, and the job YAML is the YAML I mentioned before in the Combat CI section. So it is also declarative. The grammar also support the reference expression to embed in your YAMLs like this. You could just to reference value from the running context, like the vars.os means this job, while it's before it's submitted, it will reference the OS value from its context in vars namespace, and or you could use this grammar to announce a Python expression to make some like string handling, or just make out numeric you need. And the matrix keyword it is used to announce different kinds of combination. Like if you submit a job, but you need it run in different kinds of distro, different kinds of architecture to test it. You could just use this keyword to simply make your single workflow to split to many combination, and you could use the overview of metrics in the website to simply glance how all the branch status is. And while your workflow, your pipeline occurs some arrows like a job is value, you could click the button to reproduce the same environment easily. Once you click the button, we will provide a web terminal which you could share with your partner to debug in the same web terminal, or you could just use your own terminal application to enter the environment for debug. And while you finish your debugging and make your pull request, update your Git repo, and the webhook event will trigger the new running record, and it will make the new turns of testing. The target for EulerPipeline is to support all the things of it. Like code CI means the access control on your repo, or kernel CI for the kernel repo access control, or the ISO CI, like how to build your own distro image. Like the release CI is for the release management for your community. So all of them are the CI title is for different kinds of things. They are all of them are different kinds of template, and like in code CI, the antivirus or the check SCA check license, they are all of them are atomic jobs supported by the Compass CI. So it means we could build a large ecosystem for different kinds of atomic jobs and use the template to arrange them easily. And all the thing you need to do to build your pipeline is to select a defined template and make some fine tune, like set some parameters or change some little bit details, and your pipeline will work. That's all. And if you have any interest of the CI/CD system in the open OR community, you could engage us by these ways. And any questions? Thank you.
You mentioned that different CI systems are atomic, so they do not have the same tasks, right? But
I did mention that other CI systems are atomic, and the atomic words I named before, it means just a kind of name, because the job is the minimum unit of our system is job, so we call the job is atomic job. No, but not I have not mentioned that other CI systems are atomic. Okay. We have two CI systems.
So please get back to generate ISO, we may need to check our kernels and software packages as well. So will they do the similar tasks in the two CI?
No, for your requirement, they could totally different, and they are not different system. They are all in the EulerPipeline system. They are just different kind of YAML. You could learn it like this. So all of them are templates in the grammar I mentioned before. Yes, but you could just make a new template for your requirement. You could make one template. Any questions?
Thank you everyone to attending here. I know this is last session, so everyone feel tired, but yeah, let's just start. And I'm be sure that this is just not full of information, but just really lightweight and kind of showing things. Okay, so let's just start. I'm Khanh. I'm a software engineer at cyber agent, and I'm the maintainer of the PyCD projects. And I do GitHub and Twitter. And my talk is about PyCD, but before we get started, I just had a little bit share about the challenge of the deployment on multi-cluster and multi-cloud environments. So I'm listing here is some problem we face when we do the CI/CDs for the company-wise. I'm from the CI/CD platform team, and the first one I get here is different cloud, different tools. What I mean cloud here is, say for instance, is Kubernetes, AWS, GCP. For AWS, maybe it's Lambda, ECS, or something. Anything we containerized. For GCP, we have Cloud Runs, thing like that. And if you have experience of working on some kind of environment that missing in between many things like that, or maybe it's not just your team, but for your whole organization, different team have different way to choose the platform, then you definitely face with problem like this. And the point is, for Kubernetes, we have some kind of community standard like Argo CD or Flux CD. But for the other, what do we have? We do not have any standard like that. And the next one is about the securities and observability. I know that most of people, I mean, most of company and most of team do use CI for CDs, which means that we have to share credential to the CIs. What we actually believe is we should separate the CI with the CD. The CI should focus only on the testing and building the artifacts, and the CD should be the one who take the rest from the artifacts to the cluster deployings. So it could be lead to some serious security issues if we mess up. I mean, actually use one for everything. That why I played it as a second point. And the third is, how do we do progressive deliveries to multi-clouds? For here, I have a new word. I mean, not actually new, but pretty new if you do not actually work as an CI/CD engineer, which is progressive deliveries. We know about the GitOff. We know about the continuous deliveries which is CD, but for the PD, progressive deliveries, is kind of term of using some strategies to deploy your application. If you hear about the canaries, you hear about the blue-green release, that is talking about progressive deliveries. You not actually fully deploy your application at once. You have canaries version, you test it with your user, and if everything is okay, then you go next, release everything. Or if you get any problem, you roll back automatically. That kind of simple imagine about the progressive deliveries. So what do we have as a solution for everything? I'm not sure you guys have the same imagine with me, but the first thing that come to my mind if I have to do support multi-application kind, multi-cloud is the Jenkins. I know it's still the standard for the community and for the markets, because I actually did that. I'm enjoy some conference in China and in America as well, and I asked this question: what do you use as the CD for your application, for the system? And the point is, I'm having here is Jenkins and other, which is actually the CI do the CD works. So basically, the half of the answer is CI do CD things, and the other half is we have everything on the Kubernetes that were pretty nice. So we use everything on Kubernetes, and we have Argo or Flash CD for that. And just a little bit mentioned here is the Argo really strong compared to the Flash CDs. And so what is the problem? If the CD does the CI job, then it can lead to some kind of serious security issues. For Jenkins, you may hear a lot from the committee, which is the performance issues. Basically, the Jenkins does not exist from the time when the cloud natives grow this much. So it's kind of understandable. And on the opposite side, we only have standard CD for the Kubernetes. So we have to do, for the other kind of application, like I just said before, serverless thing like Lambda, Cloud Runs, or Terraform, something like that. ECS, you have to has ton of script that running on Jenkins or some CI like GitHub Action, and it's costly to maintain that much of script cross different cloud and different application kind. So it is the gap of the markets, and we think that, and we feel that. Not just feel, but we have experience on maintaining that kind of complex CI/CD for the whole company-wise. After this, I will share you a little bit more about that later. But we start this by CD projects as team projects, and the vision of Supply CD is the one CD for all. And we want to mention here is we are CD. We focusing on only on the CD. CI probably we can use just Compass CIs or open on early pipelines, just as previous one. But for the CD, we want to make this CD as the one CD for all. It's designed to overcome the challenge across our experience of diverse application to various kind of platform and different cloud, and it has to be work easily and smoothly across the scalable organization. And a little bit of information to say about the PyCD. It's the GitOps style CD tool, and it take multiple app and multiple provider as the first citizen, and it's work well with it's fit for the larger scale organization, but it's work well with a single project as well. And its currently status is the CNCF sandbox projects. If you not know about the CNCF, it's a Linux Foundation sub foundation, and it's fully open source. Currently, we pass 3,700 commit already, and we have about nearly 80 contributor worldwide, and we're on the way to get our first 1,000 stars. So if you like, please support us. And interesting thing here is there is a bot in the contributor list, and also we have some former PTIT student as the contributor currently as well. They know me, and I invited you. Yeah, invited them to be the contributors. Leslie. Next could be the PipeCD at a glance. I will guide you some feature of PipeCD and some retrospective of the projects. First, as I said before, PipeCD is support the range of application. We currently support the Kubernetes, the AWS ECS, Lambda, the GCP Run, and the Terraform. And it is this what can I say, the simple of what you need to actually use the PipeCD in action. We have here is the Kubernetes application manifest. We have deployment, we have service, and the smallest setup, and we need to prepare PipeCD configuration YAML, and it's kind of thing like this. Basically, it's define the pipeline of what actually it going, and a pipeline is set of state that we predefine but customizable for application guy, and we have some kind of common state as well. You can actually mix it with the application guys, so build up your pipeline, and this is what you get with this kind of pipelines. And the nice point is it's work not just for Kubernetes but the other application platform as well. And this is a sample for the cloud runs. We see here is the same things. We have service.yaml, which is the setup manifest for the GCP cloud run, and we have the pipeline definition YAML, and we get this one pretty same. And next retrospective is PipeCD integrates with the Kubernetes ecosystem easily. PipeCD work well with customized ham on or Istio, if you know whatever from here. And next thing I'm showing you here is the simple UI for the deployment details of PipeCD. We have here is the pipeline I just showed you before. It's combined of 4 different states, and we have state log and clicking allow right here. This one is application detail page, where I want to talk a little bit about this one. This one is drift detection feature of PipeCD. Is compare the manifest and the in cluster state, and if it find any different, it's showing here, and you can trigger the recycle of your application from here. Basically, PipeCD work. We have 4 kind of trigger, which is on git chain, on diff detection, on manual click, or on chains. I will talk about on-chain trigger later. Next is the overview of the PipeCD architecture. This is the reason why PipeCD, I said, is work well with the large-scale organization, as well as working well with the simple project as well. We see here that PipeCD combine from 2 components, one centric control planes, and many PipeCD, we call it an agent. So in a simple way, the platform team, I mean the whole companies only need to have one centric control planes, and basically the team or the platform team when operating this control plane, and it's a stateful component, while the agent is stateless component. Every product team, developer team can install it inside their cluster, and it's just a single binary anywhere, and we test it running as a Kubernetes pod, or just in the VM as a process, or is as a serverless handler. Anything, it just work well. And when we talk about scale, we have one centric control plane that actually the platform team need to care about. Why the company wide scaling? We have new team, we have new project, we have new cluster. Just install that agent to that cluster. That all, and everything working well, at least in our case. And if you are platform engineer team who maintain the CI/CD for the whole companies, your job is install the control plane, and operating is. I can say that it's much less work compared to my previous experience when I have to maintain the whole Jenkins thing. Also with the Argo's updating, if you use Kubernetes and you Argo, when you update your Kubernetes cluster, you have to ensure that the Argo is still working on that. Or vice versa, when you update Argo, you have to ensure that your current Kubernetes cluster is still working. Something like that. For PyCD, platform team has to maintain the control plane only, and it's basically a Kubernetes application, but it's well containerized, so you can actually install each component as well. But it's recommend to just using ham install command, and everything will go up. And it's even easier when you look closely. We have 5 components inside the control plane, but this two is the cloud provide managed service, which is say this one can be RDS, yes, RDS, or Cloud SQL from GCP, Aurora from AWS, uh, whatever else. I mean, it support currently MySQL and FileStore from GCP, and the FileStore is just AWS S3 or GCP GCS, and I mean, is cloud provide managed being bad. So the PyCD architecture have we avoid that by making the agent running in cluster. Your agent will has the creator to actually touch the application in the cluster, and also it has the way to connecting to the Git, quick pulling the application manifest, and that all the control plane do not know anything about that cluster. Your creator is safe in your cluster, and that was the voice, not leaking anywhere. Also, every request from the agent to the control plane is polling model. Is outbound request only. Quick means that the platform team who has maintaining the control planes do not need to know what and where your agent be installed. It's just the place of just split we storing the application state on deployment. That all. So it's way safer. Also, PyC have some security feature as well. We have a built-in secret management. Basically, this one is templating feature that support you. You can storing your things, password or creator beside with your manifest. And we have RBug as well. I think it's fair enough for production ready things. Also for the SSO login things. Okay, so next one is progressive deliveries. As I said before, progressive deliveries is about how to automatically deploy the new version to subset of your user, and then evaluate any problems, any correctness, any performance issue before running in to the old user to reduce the effects. If you actually do kind of B2B or B2C service, you can understand what I mean, especially B2B. They really care about the uptime, the non code bug-free environment. So this is the thing that we should care about if we actually care about our user. And PyCD have this state with names analyst state. Basically, this state will perform some kind of prompt keyouts to the canary run out workload, and actually testing something that you writing down. And if anything wrong happen, it's automatically trigger the rollback. And it's not only for Kubernetes, but the other as well. Oh, sorry, I missed a slide. Okay, so internally the analyst state basically is the PyBD agent connect to some kind of metrics exporting service like Prometheus or Datadog. We currently be supported by PyCD, and it's perform the prompt KLs queries, and we have kind of threshold or something like that. And if you find something wrong, then it's trigger the rollback. Okay, next one is the deployment change feature of PyCD. We have here is kind of application finish, then trigger next application, then trigger next application deployments. Which I have here is a simple use case where we have Terraform like as an IAC for your cluster. Then after this one is updated, then you update, you trigger the deployment for the Kubernetes application or Cloud Run application at the same time, and then you trigger the update for the next application. Is everything run on chain? And another use case is we have developed environment application. We have to test this one first. Then if everything fine, then we go to deploy the staging environment, then go for the production environments. Or as our company's use case, we have multi-lesion application as well, service as well. So we can release to the Asia first, then US, then Europe. Is minimize the impact to the end user by grouping them by location. Okay, so next one is check for key feature of PyCD. So if you know about the DORA, I mean the 4 keys feature to actually has some inspiration of your development process. You will understand what I mean. For here, we support 2 metrics for the inside to the application deployments, which is deployment frequencies and the chain fail rate. Okay, so there is a lot more feature of PyCD you can test by yourself. If you we have a live demo here, so you can access it and click around. Just need to log in using your GitHub account. Then you can clicking around and viewing things. One of the feature I want to talk right here is we can integrate. We are CD things and we are focusing only on CD, but we can integrate easily with any CI. You can just using the CI, and as the last step of the CI, you trigger the deployment by send an event to the control plane. Then the CD by CD can perform the rest of the pipeline at the CD part. Okay, so a little bit say about PyCD at my company. Currently, the PyCD handle 1 centrics. Control planes can handle about 3,500 applications, and it's